Hi guys, please take out your packet. I'm on page 15. It's the page that we were doing before the bell rang today. So I just wanted to review the 4 problems that we did before I go on to some new examples. The purpose for 1 and 2 was to show you that it doesn't matter if you're square rooting first then squaring or vice versa, you still get the answer to be 32. However, it matters when the radicand is a negative. So if I did negative 4 squared first, which is 16, square root of 16 is positive 4. But in this case, when it's the squared is outside, not inside, you don't get the same answer. So that was the purpose of these 4 examples, to show you if it's positive, you just get 32 regardless of where the square is. But if it's negative, different things happen. The other purpose is to show you that, so I'm going to hold off on this right now. I'm going to compare this one to this one, right? They both have a squared inside. So if they both have a squared inside, it's not just that the square root symbol and the squared disappear because they're inverses. Here you're just left with 32. That's not what happens here. The square root symbol and the squared, if they disappear, then you would be left with negative 4. But we know the answer is not negative 4, it's positive 4. So weird things happen when you have a negative inside. So let's look at number 4. It's the square root and it's x squared, right? You think that it would just the squared and the square root would poof disappear, so you're left with x. Careful though. Here, like if x, here x is negative 4. Was I just left with negative 4? I wasn't. I was left with its absolute value. So I want to make sure you understand that the answer for number 4 is not just x. If you're confused, take a look at number 3. Number 3, the answer was not negative 4. The square root and the square symbol, poof, just don't disappear. Because if that was the case, then we would write down negative 4, but negative 4 is not the answer. The answer is the absolute value of that. So for number 4, the answer is not just x, it's the absolute value of x. If you're confused, think about if I made up the square root of 9 squared. You would say 9. But what if I had the square root of negative 9 squared? You wouldn't say negative 9, you would still say positive 9. This is why the answer is the absolute value of x. Okay, so before you do some of the problems that I'm assigning for homework, I want to review, or I want to do some examples with you. All right, so let's look at higher roots. Number 8 is actually a very good problem to look at. We're taking the cube root of 15 cubed. We're obviously not going to do 15 times 15 times 15 and then take the cube root. You know the cube rooting and cubing are inverses of each other, so the answer is just 15. Let's look at another one. Now the radicand is 14 to the nth power, and then n is just a constant. It could be cube root. It could be the 8th root of 14 to the 8th. It could be the 11th root of 14 to the 11th power. So as long as the index is the same as the exponent, you know, they're inverses of each other. The 8th root and raising it to the 8th power, 11th root raising it to the 11th power. So the answer for number 9 is just 14. This is what my next few examples are going to be based on. For us to simplify higher radicals, like we have the 4th root here, and then when we have variables inside. So I'm going to take a look at an example. You can write these down or you can just pay attention. What if you had the square root of 15 to the 4th?